Okay, hello everyone, and welcome. We are going to continue to solve systems of linear equations. And today we're going to use a technique called elimination. Again, today's objective is to solve a systems of linear equations. That's right, using elimination. And the essential question is, how can we use elimination to solve a system of two linear equations? Okay? All right, just to kind of review here, there are three methods now that we have learned on solving systems of linear equations. First one we did was we solved by graphing. We graphed both lines and found the intersection. That's easy to do if it's like whole numbers. You can see it, but sometimes it's hard to see. We used substitution, all right, when one or both of the equations is already solved for a variable, or it's really easy to solve one for one of the variables. So substitution is easy to use. All right, we use elimination, though, when it's not so easy to solve, all right, for one or variable or the other. But they do have what's called an additive inverse. If we add these two equations together, we actually eliminate one of the variables. And that's the technique we're going to use. Now, first, a couple vocabulary words. The coefficient, and we've talked about it before. It's the number used to multiply a variable. It's the number that's in front of the x or the y. All right? It's placed before the variable in an algebraic expression. It's called a coefficient. All right, vocabulary word number 2 is called additive inverse. And additive inverse is just always add up to 0. You can think of them as the opposites. All right, a plus negative a equals 0. All right, look at these right here. 2x. The additive inverse, or the opposite of 2x, is negative 2x. When you add those two together, you get 0. All right, the same here with 3y. Negative 3y plus 3y is 0. They're additive inverses of each other. All right, again, vocabulary number 3, we've talked about this as well, standard form of a linear equation. 8x plus by equals c, where a, b, and c are whole numbers and a is always positive. All right, you have the elimination method. Let me get myself out of the way here. It's when an additive inverse is used to eliminate one of the variables. All right, you can see like right here, 4x minus 2y equals negative 2. And 3x plus 2y equals negative 12. If we add those two equations together, add them up, we eliminate the y. Because negative 2y and 2y are additive inverses. We eliminate the y. And that's easy to solve for x. And then you plug it back in. I'll take a look at this one right here. 2x and negative 2x. When we add those together, the x is eliminated. All right, then it's just easy to solve for the y. An example number 1. Now, it's when we already have an additive inverse. Like this one right here, we talked about it. Negative 2y, positive 2y. This is our system of linear equations. There's two linear equations. Again, we're trying to solve this system. We're trying to find where those two lines intersect. When you add them together, you eliminate the y. We end up with 5x equals 10. Well, okay, so x is 2. So we can plug x equals 2 back into one of the original equations and find out what y is. Y is 1/2. All right, and we can plug it back into the other one too, just to find out to make sure. All right, 2 plus 1 equals 3, yes. All right, and our answer is an ordered pair, x, y. 2 and a half. All right, that's our answer. All right, example number 2 is when one equation needs to be multiplied by some number to create an additive inverse. Or as an example, here's our systems of linear equations, these two equations right here. I can't just add them up. I won't eliminate a variable. But if I multiply this top equation by -5, everything by -5, then I create a -5x. And that's an additive inverse to the 5x of the other equation. So when I add them up, that's 0. It eliminates the x. All right, this equation right here is this top equation multiplied times -5. All right, when I eliminate the x, I solve for y, I get y equals -1. And again, I can plug it back into one of the original equations and find out what x is then. And then write my answer as an ordered pair. All right, example number 3 is when both equations need to be multiplied by some number to create an additive inverse. Again, we are forcing an additive inverse. So we can eliminate a variable by adding up the equations. All right, here it's 2x and 3x. So let's just multiply this top one by 3 and the bottom one by -2. All right, we could also eliminate the y here. We could multiply the top by 5 and the bottom times -4 and eliminate the y. But here we're doing it this way to eliminate the x because we get 6x and -6x. All right, we add them together, it eliminates it. We end up with y equals 4. Plug it back into the original equation, one of them, and we get x equals -3. Then just double check the x, y in that other equation, and it does work. All right, y'all, here are the steps for solving using elimination. Again, put both equations in standard form, and then create an additive inverse if you need to. All right, add the two equations together, which eliminates one of the variables. Solve for the first variable, then plug the first variable into one of the equations, one of the original equations, to solve for that second variable. And then check your answer and write as an ordered pair, okay? All right, guys, you can take a look at the homework check. You can do it now. It should be open. But we'll look at it in class as well. All right, that's it. Thank you.